Hey, what's up, guys? Today's video notes are going to be on adding and subtracting fractions. Now, I know that this is an idea that we've gone through before in school, in math classes, but I did want to just take a day to review it. Not only to make sure that we've covered it and make sure that we're on the same page in case we run into more problems that involve adding and subtracting fractions, but also because there is a trick for a certain type of these problems that I think makes this just a little bit easier, and I wanted to have a chance to show you all that. So these problems basically break down into three types. The first type are the type of problems that have, or where you have the same or common denominator in both of your fractions. So for instance, if I were to write 2/9 plus 5/9. Now, denominator, remember, is the number at the bottom of your fraction. We consider these fractions to have common denominators because they're both the same number, 2/9 and 5/9. And if I want to add these, essentially, or what I need to do, it's supposed to be an equal sign. Essentially, I need to add my numerators, I need to add my top numbers, but my denominator, my bottom number, needs to stay the same. And I'm going to go ahead and use brown color. So when I write them in brown, you don't have to write it. It's just a quick little thing that I do with notes sometimes. If we think of this as 2 cups of something, like 2 cups of water, plus 5 cups of water, we're not worried about this unit. That unit is going to stay exactly the same. It'll still be some number of cups. We'll just add however many cups we have. So 2 cups plus 5 cups doesn't give us 7 anything weird, it just gives us 7 cups. The reason is that cups is our unit of measurement. And in the same way, a denominator is a bit like a unit of measurement when we add fractions. 2/9 plus 5/9 works the same way as 2 cups plus 5 cups. We add our numbers, keep the unit, and keep the denominator. So after all that work, we can finally get an answer to this, which is 7/9. So with this kind of problem, all you do is you look for your common denominator and then you add. This also works if you subtract. For instance, if I were to write, what was the other one I was going to do? 7/8 minus 3/8. I would do the exact same thing, except I would remember that I'm subtracting. So that equals 7 minus 3. I take my numerators, my 7 and my 3, and I subtract them. Put them over my same denominator. And then from there, it's a quick bit of subtraction. Now, 4/8. This is something that we can simplify. We can look at 4, we can look at 8, and we can realize, oh, that's just 4 times 1. That's just 4 times 2. So if I get rid of the 4 that I'm multiplying in both the top and the bottom, I can think of this as 1/2. So that's a very quick review of simplifying. Not all the problems that you'll do today will have you work through this, but I did just want to show you that it could happen. So I'm going to go ahead and skip to the next page here. So for type 2, this is a type of problem where we have a different denominator in our fractions. but one of our denominators is a factor of the other. Let me show you an example of this. For instance, 2/5 plus 3/10. Let me get out brown for this one again. Now 5 is a factor of 10. 5 goes into 10 evenly. In fact, 10 is just 5 times 2. What I'm going to do for this type of problem, where one of my denominators is a factor of the other one, is I'm going to look at my smaller denominator, so in this case 2/5, and then I'm going to take whatever or however many times the smaller denominator goes into the bigger one, in this case 2. And let me use green for this. That number, the number of times my smaller denominator went into my bigger one, I'm going to take that number and I'm going to make it into a whole number fraction. 2 over 2 is the same thing as the number 1. So if I multiply 2/5 by 2 over 2, I am not actually changing this number. I'm not changing its value. I'm making it something equivalent. I'm writing it in a bit of a different way in order to make things easier for myself. Because what this is going to do is, now if you remember how to multiply fractions, we just multiply across the top. So 2 times 2 gets me 4 for my new numerator. 2 times 5 gets me 10 for my new denominator. And now I can add this to 3/10 and use the same process that I did for a type 1 problem. 4/10 plus 3/10 gives me a final answer of 7/10, and I don't need to simplify that. So that is my answer, 7/10. Once again, this kind of problem can also be solved if you see subtraction. If I have 4/7 minus 2/35, for instance. If I compare my denominators, 7 and 35, 35 is just 7 times 5. So this number, the number of times my left denominator went into my right denominator, I'm going to bring over here, and it's going to become my whole number fraction. Go ahead and erase this, just for the sake of getting rid of clutter. All right, and now on the left side, I need to multiply 5 times 4 to get 20, and I need to multiply 5 times 7 to get 35. Everything in red that I'm writing here I haven't changed. I'm still subtracting 2 over 35. And just like the type 1 problems, I can do a simple bit of subtraction. 20 minus 2 is 18 over 35, and that can't be simplified. So I'm done with this problem. Now I'm going to go ahead and start writing about type 3 and write down 2 examples. The actual method, though, I'm going to have to go over to another screen and insert another video clip to do. So after I write this stuff, you'll see a weird cut to a different screen, but I hope it'll be okay. Okay, now my only goal in bringing you here to this math program that I use for our warm-ups is to show you the visual and the reasoning behind this shortcut trick that I'm going to give you. So I don't need you to take notes. I'll just ask you to take notes when we jump back to my iPad for the very last part of this. But for now, I have the first example that I need us to go over, 2/3 plus 1/4 pulled up. and I want to show us the shortcut for this. Now, many of you have probably done some trick where you take your right denominator and you multiply your left fraction by it. So 2/3 becomes 4 times 2 over 4 times 3 for now 8 over 12. And then similarly, I would bring 3 over, multiply. I know that looks a bit more like a minus sign, but that's fine. And then we multiply the right fraction by 3 over 3. 1 times 3 is our new numerator, 4 times 3 is our new denominator. These denominators come out to be 12, and they're the same, so we can add them. We just add 4 times 2 and then 1 times 3 to get 11 over 12. Now that is going to be our answer. We're eventually going to get 11 over 12. But the shortcut that I like to show you simplifies this process a little bit. It does, however, mean that we're using different methods to find our numerator and denominator. So let's start with our denominator. To start with our denominator, I actually want to show you this. So I think you can see what's happened. I have drawn columns into this grid that was originally split into rows. I've drawn rows into this grid that was originally split into columns. Each of these grids now has 12 boxes in total. Not necessarily filled in, but in total. So to get our new denominator, we just need to multiply the number of rows by the number of columns. We just need to multiply 3 times 4. So 3 times 4 gave us 12. Even if we didn't know the answer, we would know at this point that the denominator of our answer would be something over 12, some fraction out of 12. Now, how do we get that numerator? Well, whether you remember from seeing the original method or whether you can kind of visually pick this out, we have two numbers in the original problem reflected in this red grid, 2 and 4. 2 rows, 4 columns. This red grid is split into the grid is split into 12 cells, but now 2 times 4 of them, or 8 of them, are filled in. Similarly, over here in the blue one, 3 times 1 of them are filled in. 3 rows, 1 column. This shows us that to find our new numerator, we need to cross multiply. 2 times 4 like the red grid. 3 times 1 like the blue grid. In any case, we have our rows times our columns to get the total number of cells that have been filled in, and then we can just see that we're supposed to multiply and then add by order of operations. Now this, I want to go ahead and show one very quick thing. This looks a lot like where we would get to if we use the other method. 2 times 4, or 8 twelfths, plus 3 times 1, or 3 twelfths. If we use the original method, we'd end up with 8 twelfths plus 3 twelfths. This, like I said, just simplifies the process. And those of you who've done the arithmetic, you would probably have seen that 2 times 4 is 8, 3 times 1 is 3, meaning that our answer is 11 over 12. And we don't have to simplify this, so we're not going to do anything else with that. So I'm going to go ahead and reset this and pull up the other example, which was 10 elevenths minus 3 fifths. And this was a subtraction one. Let me scoot this over so it doesn't look as weird. All right, so 10 elevenths minus 3 fifths. So let me start by splitting the grids up. Each of these grids now is divided into 55 very small boxes. Where do we get 55 from? We get 55 from multiplying our denominators to get our new denominator. So whatever this fraction comes out to be, we know that before we simplify it or turn it into a mixed number, if we have to do that, it's going to be something out of 55. All right, so then how do we get our numerator? Well, we are going to cross multiply. We're going to take 10 times 5, which I think you can once again see reflected in the red grid. 10 rows and 5 columns are filled in. We're going to take 11 times 3, which I think you can see from 11 rows and 3 columns being filled in the blue grid. And we're going to subtract those. Now, I want to point out one thing. Order matters in subtraction. It doesn't matter as much in addition. You can flip around two numbers that you're adding and you'll get the same answer. But if we subtract, we need to keep the left numerator on the left. So even though we took 10 and multiplied by 5, we're still keeping that little multiplication on the left. and then our 3 is staying on the right. So our numerator of 10 in the left fraction stays in the left. Our numerator of 3 in the right fraction stays on the right when we do our subtraction. And those of you who have done the arithmetic, you would probably have seen that 10 times 5 is 55. 11 times, or nope, that is just 50. That is my fault. I was actually multiplying 10 times 11. Or no, 11 times 5. Goodness. 10 times 5 is 50. 11 times 3 is 33. 50 over 55 minus 33 over 55 is going to give us a final answer of 17 over 55. This does not need to be simplified, or it can't be simplified. So that is everything I wanted to show you for this trick. I'm going to jump back to my iPad now, but I will say that I will have this pulled up on my computer up front where I have this math program. And if you need the solution to a problem worked out, even as a quick little visual, you can do that. I also program this to where it can show how to reduce a fraction when you get it as your answer, or turn it into a mixed number if you need to. All right, so now that we're back to the iPad, I do need you guys to start taking notes on this, because I'm going to actually go through these examples with just writing out this process, with just writing out this shortcut. And again, if the other method works better for you, go right ahead. But I'll go ahead and just do these two problems using this method here. All right, so 2/3 plus 1/4. To get my denominator, I just multiply the two denominators for my original fraction. So 3 times 4 is 12. I know my fraction is going to be something out of 12. To get my new numerator, I cross multiply. So 2 times 4, 3 times 1. And I know that this is going to equal 8 plus 3, which equals 11. And again, these fractions are all out of 12. Nice thing about this trick is that you just find your denominator first, and the math for the numerator you can kind of just write in as you keep going. So this fraction is 11/12. And then down at the bottom for the second example, to get my new denominator, I multiply my original denominators. So I know my new fraction is going to be something over 55. To get my new numerator, I start at the top left corner and then multiply on that diagonal, 10 times 5. I'm going to subtract from that 11 times 3. So once again, my left, let me write this in brown. Once again, my left numerator, its multiplication expression is down the left. My right numerator, its multiplication expression is on the right. I need to keep my left and right numerators consistent. But let me go ahead and erase this for the sake of getting rid of clutter. There it is. So all my fractions need to be out of 55. 10 times 5 is 50. 11 times 3 is 33, giving me 50 minus 33, which gives me 17. So that is So that's the process for type 3 adding or subtracting fraction problems. The trickiest thing with this is if you come across a subtraction problem, to keep your numerators consistent. Your left numerator needs to stay on the left, your right numerator needs to stay on the right. Good luck on your work today, especially if you're in the class where I won't be here. Once again, I'm going to have the visual that I showed on my computer pulled up, so that if you need to use it, if you want to use it to pull up a problem, then you can. With that, best of luck.